Hi, I'm going to do an example of finding the equivalent resistance by using graph isomorphism in a circuit where there is only independent sources. Okay, so I've already drawn out the circuit as it is in time larger than 0, and I already killed all the sources. And I labeled all the nodes for convenience to save us some time. And this method take advantage of the fact that throughout the same node, the voltage is going to be the same. What this means is that the voltage here is going to be exactly the voltage here. So using this knowledge, we can basically shorten every node down to one single point. So this is what I'm going to do. And what we're trying to find is the equivalent resistance as seen by the inductor. So basically, we're trying to find the equivalent resistance between the purple node and the blue node. And we can see each resistor as a path between two nodes. So I'm going to write them as edges in this graph while I represent the node as vertices. Okay. So here we have a 10 ohm resistor. Oh, by the way, I'm using the same color for each node. For this 10 ohm resistor, it's connecting the blue node and the red node. So I have a 10 ohm here. For the 15 ohm resistor, it's between the red node and the green node. So here is 15. And for the 9 ohm resistor, it's between the green node and the purple node. Here is 9. And here's a 6 between red and purple. Finally, here's a 9 between red, this is ugly, between red and blue. And here's a 8 between blue and light blue. Okay, so now we've identified all of the resistors. We have all the edges and all the vertices in this graph. We can go ahead and simplify this. Okay, so the first thing I observe is that this 10 ohm and this 8 ohm are connected in series because they're not really involving, we're not really eliminating the purple node or the blue node, which are the nodes we really care about. We can simply eliminate this dark blue node. Okay, and we can say since they're connected in series, we can say there's a path between the red node and the light blue node, which has the length of 18. Okay, great. And then we can do the same thing with these two paths since they're connected in series. So the 15 and the 9 connected by a green node in series, we can eliminate the green node and just say the purple node and the red node are connected by a 24 ohm edge. Okay, so right now it's fairly obvious that between the purple node and the blue node, there's just two circuits that are connected in series, and each of these circuits are parallel. But we can further simplify this, all right? So since the 6 ohm resistor and the 24 ohm resistor are connected in parallel between the purple node and the red node, we can simplify them to one path. And that path would have a length of 1 over 6 plus 1 over 24. And then we have these 9 and 18 resistor connected in parallel, and we can simplify them as 1 over 9 plus 1 over 18. Okay, and then it's fairly obvious that these two are connected in series. So just delete this red node, redraw it, and just add up the values. Okay, so here's how we find our equivalent. Hopefully that's helpful. If it's a little bit confusing, feel free to reach out to me and ask for clarifications. The easiest way is just to leave a comment, or I'll leave a link for contact info as well.